Fine. Now listen, in thermodynamics, right, there is a first thing which is known as zeroth law of thermodynamics. What is zeroth law? Zeroth law of thermodynamics. What is zeroth law? It says that when an object A, a body A, is in thermal equilibrium with a object B or a body B, and B is in thermal equilibrium with C, then C and A will be in thermal equilibrium with each other. Getting it? Right? What
Yes,
do you
sir.
mean by a thermal equilibrium? That means the rate of flow of heat from here and here will be same. The rate of flow of heat from B to C and C to B will be same. That means they have same what?
Temperature.
Yeah.
Temperature.
So then they have
Temperature.
thermal equilibrium. You know that, no? Whenever a hotter body is connected with a colder body, then what will happen? The heat will flow from a hotter body to a colder body till their temperature becomes,
Equal.
yeah. And that state is known as state of thermal equilibrium, right?
Yes, sir.
Very good. Now, just tell me, what is first law of thermodynamics?
The first law of thermodynamics states that energy can neither be created nor be destroyed. It
Uh,
can only change from one form to another.
Correct. That means there is a conservation of energy, right? Conservation of energy in universe, right?
Yes.
Yeah. That means any the energy content of the universe is constant, right? Now listen over here. Very simple thing. Suppose if I have an object or a body, right? Let's say this is a person. I have given, let's say, 2000 joules of energy to that person, right? So how much amount of heat I have given to him? 2000. Whenever the heat is given to the system, it is positive or negative?
Negative.
Positive.
Positive.
It is absorbing. See, whenever I'm talking with respect to system, right? If the system is absorbing, that means the Q is
Positive.
positive. If the system is losing, then the Q is
Negative.
very good.
Negative.
Now understand that this guy has absorbed 2000 joules of energy and he has spent some energy to do work. So he's doing some work. And to do work, he has spent, let's say, 800 joules of energy. Now tell me, what is the net internal energy change in the particular this in the particular human body, right? If I'm giving 2000 joules, he has used 800 joules to do work. Then what is the net energy which will be stored in this person?
1200.
That is
1200
that
joules.
is
1200.
that is first law of thermodynamics. Getting it? According
Yes,
to
sir.
first law of thermodynamics, Q is equal to du minus W. Getting it? Now I'll come to the very main point over here. Just understand one thing. This is a very important thing, and I'll be asking you a very important question, which will reduce 25% of the pressure from your brain. Right now, just tell me what is the difference between reversible and irreversible process. I want to know what is a reversible process, what is an irreversible process. Yeah.
Reversible means which can come back to its original state.
Okay. See, the thing is, reversible process is a process which will occur in many small steps, and every step the change is negligible, and the system will always be in equilibrium with surrounding. Irreversible process is the one where there is sudden change and there is no equilibrium between system and surrounding during the change, right? Right?
Yes,
Yes,
sir.
sir.
Explain me in basic layman terminology what is reversible or irreversible process. This is the bookish definition. I don't want that. I just want the real feel of it. Now, what exactly is a reversible process and what exactly is an irreversible process?
So
See,
to give an example of reversible process, we can, matlab, in general terms, we can take for example of eyes also. Like we can see very small changes, but it can be converted back.
the thing is, what you have done, you have transformed the same bookish language into a very practical aspect, but the thing remains the same, right? Right?
Yes, sir.
Now, I'm not asking this. Now, understand one thing. I'll ask you very simple question. Is it possible for surrounding to change in reversible process? Is the surrounding is changing, like the pressure, temperature of surrounding is changing?
Yes.
Hey everyone,
Yes, sir.
the
Yes, sir. The surrounding pressure is variable in the reversible reaction.
and what about temperature of surrounding?
Yes. So both vary to maintain the equilibrium.
See, the thing is, initial change occur in which part, surrounding or system?
Surrounding.
In reversible process, initial change occurs in surrounding and corresponding change will occur in system. Just tell me what all variable of system and surrounding will remain in equilibrium with each other. See, this is the system. In reversible process, every time this is P internal, which will always be equal to whom? P
External.
external.
PX.
I have T internal, which is always be equal to
P
P
external.
external.
The
Getting it?
external.
What about volume? Internal volume, that is the volume of the system, will be
Volume external.
cannot
Will
be.
not be equal.
Cannot be.
Not
Why?
be
Because surrounding is vast. What is the volume of surrounding? Infinite. If you consider
Yes, sir.
yourself in the system, then the overall surrounding, the space encapsulating you, is surrounding, right? Right?
Yes, sir.
Yes.
Yeah.
Yes.
Correct.
So where is your volume is equal to surrounding volume?
No, sir.
No, it cannot be, right? Acha. Now in irreversible process, what happens? The change is large.
We can see the change happening.
Okay. And during the change, what will happen?
So the external pressure is constant throughout.
External pressure and external
Temperature
temperature is
constant.
constant.
constant. Getting a point?
Yes, sir.
Getting a point? Acha, tell me, shall I say all the irreversible process which is occurring in the system are spontaneous? See, that
Yes,
is
sir.
what they are known as irreversible process, right? A sudden change is happening, and all the irreversible processes are spontaneous. That means the process which occur by its own, or once initiated, they are happening by its own. Getting it?
Yes, sir.
Now, understand one more thing. I'm just writing an equation. Just tell me whether I'm right or not. Every spontaneous process ends up at equilibrium. Am I right or wrong?
Correct.
Yeah, tell me whether I'm right or
No, sir. No, sir.
why is it so?
So only the initial and the final state becomes in equilibrium, is in equilibrium.
No, no, initial state can never be in equilibrium, beta. Just tell me, what about this process? Suppose if I have this particular process where the gas has a pressure of 4 atm, the external pressure is 2 atm, right? What will happen to this piston? What this gas will do?
The
It will
volume
push it up
increases.
Now it will push it up. Till what extent it will push it up?
until the pressure in the
Till the
system
pressure
is
becomes
2
equal to
atm
280.
When it is happening by its own, or you are just pulling the piston every time
on its own.
by its own. Will it be spontaneous or non-spontaneous?
Spontaneous.
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 Irreversible or irreversible?
Reversible.
Irreversible. And finally, when the process stops,
In equilibrium.
yeah, exactly.
280
That
and
means
280.
every irreversible process stops at reversible condition. Getting it? Getting it?
Sir, can you
Yes.
Yes,
explain
sir.
this
Yes, sir.
irreversible part
Yeah.
Yes,
again?
sir.
There's one person is asking something. Tell me, Vita.
Can you explain this irreversible part again?
Yeah, in irreversible process, the external pressure, that is 2 atm, or external temperature will never change. Getting it? Now, every time, just tell me if I've
Yes, sir.
started with in a gas system which has an internal pressure of 4 atm. Now, 4 atm is more than 2 atm, right? So, what will
Ye-
happen? The gas will push this piston away from itself, the volume increases.
Yes.
Now, if the volume increasing, it is doing some work, and finally the pressure becomes same. Then the process stops, right?
Yes,
When
sir.
the process stops, then the pressure should be
Equal.
equal. That means every irreversible process stops a reversible condition. There will be a final equilibrium. What is happening in reversible condition? There is always an equilibrium, right? Between
Yes.
internal variables and external variables, and which all variables will be in equilibrium with each other, guys?
Pressure,
Internal
And
pressure and
pressure
pressure
temperature.
and temperature.
pressure and temperature. Now what I'm doing, I'm just making it slightly more simple here. I'm taking irreversible isothermal process. Hey, what is isothermal process?
Temperature
Temperature
is
Temperature
constant.
remains
increases.
constant.
Temperature. Oh, make it like, I'll do one thing, I'll take irreversible isobaric process. What is isobaric process?
Pressure
Pressure
Where the
remains
remains,
Pressure
constant.
remains
constant.
constant.
Okay, irreversible isobaric process. Just tell me one thing. What exactly happens over here? Okay, I have taken a system, correct? Now understand that internal pressure is 2 atm, external pressure is 2 atm. Any doubt in that? And the pressure remains constant throughout the process. Take care. Now initial volume, let's say I have taken it as 1 liter, and initial temperature I have taken it as 300 Kelvin. Correct? Correct.
Yes, sir.
Now what exactly happened? Isobarically, it will expand to double of its volume. Final volume become how much?
2 liters.
Exactly. So proud of you. Initial was 1 liter, now final is 2 liters. Just tell me, what about the final temperature? If
It
pressure
will
is same,
increase. In,
number of moles remains same. What about the final temperature?
it will
It will
increase.
increase.
How much?
Temperature.
PV is equal to,
NRT.
NRT.
and the pressure is constant, number of moles is constant, R is gas constant, and volume is directly proportional to
R is
Temperature.
constant.
Temperature.
Temperature
when the
Temperature.
volume
600K.
become double, temperature should become
Double.
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 Now
$600K.
at this step, the process stops. Getting it?
Yes, sir.
I want to know what is the temperature of surrounding.
It remains constant.
Very good. How much it is?
600K.
Exactly. What I told you, finally, the system will be in equilibrium, right? Every irreversible process stops at Stops at
Equilibrium with the system.
equilibrium. That means
Reversible
pressure is already same. The leftover part is temperature. So temperature of system, final temperature of system will be equal to temperature of surrounding. Yes or no?
Yes.
Yes,
That
sir.
means
Yes.
understand initially I have 600 Kelvin, so that is surrounding temperature. Now which is hotter, surrounding or system?
Surrounding.
That
Surrounding.
means
Surrounding.
the heat will flow from a,
Surrounding to system.
and it will happen spontaneously, or you are giving the heat by every time
Spontaneously.
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 till when it happens.
Till it attains equilibrium.
That's
Till
what I'm
the
saying. That
internal
is
temperature
why
becomes 600 Kelvin.
exactly that is why the process is
Irreversible.
Reversible.
understood. How to actually visualize irreversible isobaric process.
Yes, sir.
Understood? Yeah, great.
Yes, sir.
Understood. So one thing is sure for irreversible process, right? For irreversible process, let's say T2 is always equal to T external. Final temperature of system is equal to final temperature of surrounding, and final pressure is equal to P external. Any doubt in that? Because every time when the process stops, it stops at
Equilibrium.
okay, stops at equilibrium. Any doubt in that?
No, sir.
Very good. So proud of you. चलें आगे. Shall we move ahead? You understood that?
Yes, sir.
So that is the main difference between reversible and irreversible process. Getting it? Now understand one thing here, right? What is first law of thermodynamics says? It says that Q is equal to du minus.
W.
Very,
W.
very good. Now again, I have to split this thing into two particular processes. One is reversible process, other is irreversible process. Now just tell me, what about internal energy? Will it be a state function or it is a path function?
State function.
Internal
State.
energy is a state function, right?
Yes, sir.
Is a state function, right? Will it depend on the nature of process?
Hmm.
Yes.
God
Yes.
is a state function.
For
Il,
for isothermal processes, change in energy for internal will be zero, right?
God. The thing is, for every process, right? We have a particular thing that du is always equal to ncvdt, right? Whether it
Yes,
is
sir.
isobaric, isochoric, isothermal, adiabatic, or any random process, right? Any
Yes, sir.
random polytropic process. Everywhere du is equal to ncvdt, right?
Yes, sir.
Internal energy depends on the state variables. That is why it is a state function. Whenever I have a point A, I have a point B. If I am see the point A number of moles is n, temperature is T1. Point B number of moles is n, temperature is T2. Pressure is P, volume is V. Pressure is P, volume is V. Right now, if I'm doing the process like this, if I'm doing the process like this, will it depend on the path or will it depend on the initial and final variables?
Initial and
Initial
final
Initial
and
and
final
variables.
final
variables.
variables.
The internal energy of B minus internal energy of A will be only delta U, right?
Yes, sir.
So
Yes,
what
sir.
is that? A state function or path function?
State
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 function.
State
function.
function.
That means
function.
when I'm doing any change reversibly or when I'm doing the same change irreversibly, the du magnitude will always remain.
Constant.
Very good. For example, a student asked me that in isothermal process du is zero. Agreed. If I'm doing isothermal process reversibly or if I'm doing isothermal process irreversibly, what is du in both the cases?
0.
That's what. Will it depend on the path?
No.
Very good. You got that?
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Now listen, Q reversible, and see, for reversible process, it is like Q reversible is equal to du minus W reversible. Any doubt in that? Because reversible process or irreversible process only depends on work done, whether the work done is reversibly or whether the work done is what? In an irreversible manner, right? Because du is a state function, does not matter like whether it is like reversible process or irreversible process, the amount will always remain same for the same change, right? Now for q irreversible, it will be equal to du minus w irreversible. You understood what's the difference between first law? In case of reversible and irreversible process, they only varies with respect to guys, with respect to what? Hey everyone, where the difference lies? Am I audible?
Yes, sir.
Yes, sir, you are audible.
Very
Very
good, so proud of you. The where the difference lies in
Work done.
Work done.
work done. Getting it? Acha, tell me one thing. What is the work done formula? What is work done reversible? What is work done irreversible?
Sir, work done reversible is negative 2.303 times nRT log of V2 over V1.
Okay, okay. That is in case of reversible isothermal, right? Not for
Correct.
actual process, correct? Now, listen, I'll ask you a very simple question, right? Very simple question. It is suppose a student, now he is pushing a mass of 2 kgs in this direction. So he is doing work against 2 kgs, right? Agreed?
yes, sir.
Yes, sir.
Very
Yes,
good.
sir.
The same student, when I kept a mass of 4 kgs and he's just pushing that 4 kgs away. So which student is doing more work?
4 kg student.
Tell me one thing. It is a system, right? When student is doing or pushing the mass, it is doing some work. So it is spending its energy to do work, right? Correct.
Yes.
So
Yes,
work
sir.
Yes,
done
sir.
is negative or work done is positive. I am spending my energy to do work. So my energy is getting decrease or increase.
Decrease.
Decreased.
Decreased.
Very good.
Decrease.
That
Decreased.
means if the system is doing a work, is doing work, then work done is what?
Negative.
Exactly. Because I'm spending my energy, right? Tell me in which process. Acha, now tell me. This student is doing more work, or student number one is doing more work?
Number 2.
Student
Student
number
two.
two.
Very good.
Number two.
Very good. So suppose if I have an object which is massless, any work will be done.
No.
No.
Very good.
No.
Now understand one thing. Same case comes for gas. Think, you know, outside pressure is 2 atm, inside pressure is 4 atm. So what will happen? And let's
What?
say this 2 atm remains constant. Okay? Now what will happen?
Volume increases so that pressure becomes equal to 2 atm. The internal
Tell
pressure becomes equal to 2 atm.
correct. But tell me one thing. This piston is pushing which pressure? External pressure or internal pressure? It
It
is
is pushing
Internal.
internal
it is
pressure.
Internal pressure.
what? Think again. This gas is there. It has to push the piston above. What is the pressure above?
2 atm.
So if I'm a gas and I'm pushing the piston above, so it's above pressure which matters or is my pressure which matters?
Your
Above.
pressure, which matters.
It doesn't matter, na? Whether I have 50 kg of mass, whether I have 100 kg of mass. Here I am doing work against what? 2 kgs or 50 kgs?
2 kg.
2
Exactly.
kgs.
It doesn't depend on the internal pressure, right? It is pushing what?
External pressure.
Exactly. So what should be the work done? Work done is always equal to P
Minus times P
minus of P
external del T.
external D. Understood?
Yes, sir.
Understood. Now understand one more thing. For irreversible process, is P external is changing or not? Irreversible process, will the surrounding pressure changes?
No.
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 That is why work done irreversible is always equal to P external remains outside from volume V1 to V2 just integrated. So work done come out to be minus of P external delta V. Any doubt?
No, sir.
So tell me one thing. Either it is isothermal, either it is isobaric, either it is isochoric, either it is adiabatic. External pressure remains
Same.
same.
Constant.
Work done in irreversible process will always be calculated by this formula, right?
Yes, sir.
Understood?
Yes.
So irrespective of process, work done irreversible is equal to minus of p external delta v. Have I made my point clear?
Yes, sir.
Yes, sir.
Now
Yes, sir.
understand one thing. I'll just come to reversible process. Hmm? So work done in irreversible process, you come to know I'm talking about work done in reversible process. Now tell me exactly every time, right? Every time. What happens here? This is internal pressure, agreed? And this is external pressure. Every time surrounding and system will be in
Equilibrium.
very good. That means P external will always be equal to.
P internal.
That means if I'm pushing the pressure, will it be like external or will it be internal?
Inter.
Both are same, right?
Yes.
Both are
Yes,
same.
sir.
Both are same. But the thing is, so here, shall I say that work done reversible condition is equal to integral of minus P external dV. But the thing is, here external pressure is external
Variable.
pressure is
Variable.
Same.
changing. And now tell me, I want to calculate P external. I know I can apply PV is equal to nRT. Tell me, is it possible to apply PV is equal to nRT for surroundings?
No, sir.
Why?
Because the
Because
change
the
is
volume
gradual.
is infinite.
Exactly how you will calculate the amount of volume of surrounding, right? Acha, is it possible to calculate PV is equal to nRT or apply PV is equal to nRT for system?
Yes.
Yes.
That means if I apply instead of P external, I keep P internal. Will the life become simple for me or like it will become tough for me? Because
Simple.
every time pressure is
Simpler.
so shall I say that for reversible process, it is very convenient for me to apply P internal dV. Agreed?
Yes.
Yes, sir.
Understood that point? Now I can apply PV is equal to nRT for reversible processes. Any doubt in that? Now for different condition, I'll calculate different work done. Tell me if I apply these formula in different processes, P internal, for isochoric process. Tell me what is the work done?
Sorry, sir. Can you please repeat your question?
For different reversible process, right? I'm calculating the work done. Okay. So what is the work done in isochoric process?
0.
Zero.
Zero because
Zero.
dV is
Constant.
yeah dV volume is constant, dV is zero, right?
Yeah, dv 0. Sorry.
Yeah, it's okay. Now I'll come to isobaric process. Tell me in isobaric
Minus P external del V.
work done is equal to minus of P internal dV and pressure is constant or not?
It is constant.
It is constant.
V1 to V2. Shall I keep the pressure outside?
Yes.
So shall I say it will become minus of P internal delta V?
Yes, sir.
Yes, sir.
And P internal is always equal to
P external.
P external.
reversible process, right? And now I just come to isothermal. What is isothermal process?
Temperature constant.
Temperature remains constant.
Temperature remains constant, dT is 0. Any doubt? And listen, if temperature is constant, shall I say that PV is equal to constant, which is equal to nRT,
Yes,
because
sir.
the number of moles is constant, R is constant, temperature is constant, right? Right?
Yes, sir.
So tell me work done reversible in case of isothermal process. It is like minus of PdV, right? Minus of nRT by VdV. I'll get it like that because I just substituted pressure in terms of volume. Correct? From volume V1 to V2. And one of the students is saying the formula of work done, right? Now it will be equal to, give me a minute. Yeah, it will be equal to minus of nRT ln V2 by V1. Any doubt in that? So for
No, sir.
isothermal work done, it is minus of nRT ln V2 by V1. Any doubt in that? I have adiabatic.
No.
Adiabatic process. Hey, what is the condition of adiabatic process?
Work
Delta Q is constant.
delta Q is constant.
Q is 0, right? That means the heat gain or heat loss is 0. Any doubt in that?
Yes,
You
sir.
call it as delta Q in physics. In chemistry, Q is heat change. Getting it? So heat change is
Yes,
0.
sir.
Now you tell me one thing. There is no heat given or heat applied. Shall I say P1 V1 gamma is equal to P2 V2 gamma or PV gamma is equal to constant? Where
Correct.
gamma is
Yes,
equal to
sir.
Poisson's ratio Cp by Cv, right? Can I say like that
Yes, sir.
for
Yes.
adiabatic process? Yes or no?
Yes,
Yes.
sir.
Yes, sir.
Yes,
Acha,
sir.
is it valid for irreversible process also? Guys, is it valid for irreversible process also? Like P1 V1 gamma is equal to P2 V2 gamma. Can I apply it for irreversible process?
No, sir.
Only for reversible process it will work. Hey everyone, will it apply? Will it work for irreversible process?
No.
No.
No. I don't think so.
No,
No.
sir.
No, you don't think so. The thing is, for adiabatic process, when it is irreversible work done, you cannot irreversible process. You cannot apply PV gamma is equal to constant because PV gamma is equal to constants come by a derivation of P derivation using P internal, right? Instead of P external for work done. Then I'll get this thing. So this thing is used only for
Reversible
reversible
process.
process.
Reversible.
Never ever apply it for irreversible.
Irreversible.
Very good.
Irreversible.
So proud of you. Listen, what is the work done in case of adiabatic process? It is like nRT2 minus T1 divided by gamma minus 1. Any doubt in that? Or it is also equal to P2 V2 minus P1 V1 divided by gamma minus 1. Getting it?
Yes, sir.
Very good. Now listen. Now finally what I got here, I know that Q irreversible is equal to du minus w, which finally becomes q irreversible is equal to du plus p external delta v. Agreed? And from now onwards guys, please, from now onwards guys, work done you have to calculate by using p external minus of p external delta v. Whatever work done you are getting over there, change the sign and put it over here. Getting it? Getting it?
Yes,
Yes,
sir.
sir.
Good. So this is for irreversible process. Okay. Now for reversible process, now it is valid for every damn irreversible process, right? Because it doesn't depend, because p external always remain constant. Getting it?
Yes, sir.
For every irreversible process, I'll do one thing. I'll share this PDF after the lecture gets over. Okay, and I'll share the video also. So if you are missing some part over there, just fine. We'll move ahead. Okay. Q reversible. What is Q reversible? Now it depends for various processes. Like for Q reversible, it is du minus W, and W is equal to minus of PdV, right? Getting it? Getting it?
Yes, sir.
Yes, sir.
Now understand one thing. For isothermal process, Q reversible is equal to du plus 2.303 nRT ln V2 by V, sorry, log V2 by V1, because I have taken 2.303 outside. Okay, let me see. Yeah, I have converted natural log into log to the base 10, right? And just tell me, for isothermal process, temperature is equal to what? Constant. What is du?
Zero.
Zero.
Is always equal to ncv dt, right? Always. So whether any process is there, and du is equal to ncv dt for every gaseous process, right?
Yes, sir.
Where the expansion or contraction takes place, correct? Now for every gaseous process, du is equal to ncv dt. So du comes out to be 0, and q reversible will become equal to plus 2.303 nRT log V2 by V1, and work done is equal to minus of 2.303 nRT log V2 by V1. Tell me one thing, Q is positive or negative according to this formula right now? Should I
Positive.
say,
Positive.
Positive.
if I'm giving 100 joules of energy, that same 100 joules is utilizing into do work, right? See, it's very efficient process now. A system is there. What you did, you have given, let's say, 2000 joules of energy to it, and he is performing the work of 2000 joules. Getting it? Because amount of internal energy change is zero, it is not gaining energy. Whatever energy is absorbing, it is utilizing to do work. Getting it? This is isothermal process. Correct?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Correct.
Yes, sir.
Okay. For isobaric process, tell me, for isobaric process, Q reversible will be equal to du, and pressure is constant, so simply I can write down plus pdv, right? Where p is internal pressure, external pressure doesn't matter. Correct? Correct?
Correct.
Very good. So q reversible will become equal to ncv dt plus p v2 minus v1, that is dv. For isochoric process, tell me what will happen. V is equal to constant, dv is equal to 0.
Zero.
So q reversible is equal to only du. Agree?
But sir, du is zero, na?
Du is zero.
Isochoric क्या?
Yeah. So dv is zero. How is q reversible equal to zero?
One second. Who said that du is 0 for isochoric?
Oh, sorry, my bad. dv is zero. Sorry.
Yeah, dv is 0, right? V is constant, dv is 0. change in volume, right? Adiabatic. Now, what is the work done in adiabatic process? It is P2 V2 minus P1 V1 divided by gamma minus 1. And you also know that Q is equal to du minus W, that will become minus of P2 V2 minus P1 V1 divided by gamma minus 1. Any doubt in that?
No, sir.
No, sir.
Understood?
Yes, sir.
Very good. Now listen. Till here, any doubt? Whatever we have discussed over here, a quick revision of first law of thermodynamics for gases process. Any doubt in that?
Sir, I had one doubt.
Yeah.
So for adiabatic change, when Q is equal to 0, so work done for adiabatic change, could it be change in U?
Yeah, it'll be.
It will be. So I can just write it as change in U. I don't have to write P2 V2 minus P1
No,
V1.
it's fine. If you know the change in temperature, you can do that.
Okay. Yes. Thank you,
Right?
sir.
Yeah. And understand one thing, right? W, we have calculated as NR T2 minus T1, right? Divided by gamma minus 1. What is gamma? CP minus CP by CP minus 1? Correct?
Yes, sir.
Tell me one thing. W is equal to NR uh, T2 minus T1 divided by C into CV divided by CP minus CV. Any doubt in that? Just take LCM and do the calculation over there. CV will go up, CP minus CV will come in the denominator side, right? What is CP minus CV?
R.
Very good. R and
R.
R will cancel, right? Then what is NCV dt? Correct?
Q.
Delta U. NCV dt is delta U, right?
Yes, sir.
समझ में आया बात?
Yes, sir.
Great. Now listen. These are certain past year questions, right? For first law of thermodynamics, I have just taken it down so that we can apply it. 3 moles of an ideal gas expanded spontaneously into vacuum. What is external pressure?
0.
0.
0.
If the body is pushing massless object, what is the work done?
0.
0.
So what is the answer over here?
0.
0.
Done, right?
Sir.
Yes.
A gas is allowed to expand this question. A gas is allowed to expand in a well insulated container against a constant external pressure. See, whenever he blabbered a thing that is the external pressure is constant, that process becomes
Irreversible.
Irreversible.
very good. The pressure surrounding is not changing. The gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atm from initial volume 2.5 liter to final volume 4.5 liter. The change in internal energy delta U for the gas in joules will be how much?
Bombay minus 505.
Why is it so? First and foremost,
Because
what the
Q
catch,
is
what the catch point over here?
the Q is 0.
Exactly. The catch point is insulated. Whenever it is saying about insulated container, that means
There is no change in heat.
yeah. So Q becomes 0. That means Q is equal to du plus P external dV. That we know. We have calculated for irreversible process, right? So Q is equal to 0. That will become delta U will be equal to minus of P external is always P2, that is 2.5 already given to us. 2.5 atm. Tell me how to convert into Pascal. So 2.5 into 101,325, correct? Pascals. Into delta V, V2 minus V1. What is V2 minus V1?
2.
2 liters.
2 liters. And how to convert liter into meter cube?
Divide by 1000.
So multiply by 10 to minus 3. Correct? That is Pascal meter cube, which comes out to be joules, right? So you multiply this overall thing, what I'll get?
Minus 505.
Understood? Understood? Everyone?
Yes, sir.
Yes, sir.
So will be minus of 505 joules. Yeah. Shall we move ahead to the next question? I guess you would have done this question earlier also, right?
Yes, sir.
Yeah, very good. 1 mole of an ideal gas at 300 Kelvin expanded isothermally from initial volume of 1 liter to 10 liters. Calculate delta E, internal energy change.
Bombay.
Yeah.
0.
What is du? If the temperature is not changing, you know that internal energy is a function of temperature, right? Acha, on what other factors internal energy depends? Yes. On what factors internal energy depends?
सर फॉर्मूला से पता चलता है कि it depends on number of moles and CV.
ठीक है. Internal energy du depends on number of moles. CV is nature of gas, that is fine. DT, that means depend on temperature also, temperature change also, or U will depend on temperature, right? Correct?
Yes.
Yes, sir.
Pressure.
This is valid for a gaseous expansion or contraction, right? Correct.
Yes, sir.
Now, it also depends on phase transformation. For example, if a solid is converting into liquid at the same temperature, let's say take it as ice, take it as water, it will be like 0 degrees Celsius, it will be 0 degrees Celsius. This transformation occur at its melting point. Now, tell me what exactly happens.
The temperature remains constant and the internal energy increases.
1 second, will it increase or it decrease? It's
It will increase
understand why it increases.
because the energy on the molecules increases.
Okay, fine. Listen, I'm providing a delta H, right? That delta H is delta H of what? Fusion, correct? Correct. Then solid is converting to liquid. Tell me, temperature remains same. So what about the kinetic energy of the molecule? Will it be same or will it be different? If the phase transformation takes place. If I'm talking about the temperature is same. Tell me about the kinetic energy of the molecules. Will it be same? Will it be different?
It will increase.
Very good. The thing is, during the phase transformation, whatever energy you will supply, it increases its potential energy, not kinetic energy, because temperature remains.
Same.
Yeah, you got that point.
Yeah.
Yeah. So whatever energy you are providing to a particular substance for phase transformation, that energy will increase the potential energy. And what is the definition of potential energy? What is potential energy? Yeah. See, potential energy is the energy which is possessed by a system due to the force of attraction or repulsion. If you provide energy, the attractive forces decreases, right? Hey, if you provide energy to a particular molecule which are attracting each other, the temperature what will happen? Energy content increases, they will move away. What about the attraction? What will happen to the attraction?
It will decrease.
Very good. If it is decreasing, potential energy become positive, right? Potential energy become negative when the attraction increases.
Yes.
It releases energy. Understood?
Yes, sir.
Very good. Now come there. In a closed insulated container, a liquid is stirred with a paddle. देखो यार, एक closed container है. I have a liquid which is stirred with a paddle. What will happen? I'm doing work on this particular liquid part, right? And it is closed container. Insulated, that means Q is 0. So whatever work you are doing, will it increase the energy of what? Liquid, right? You're doing some work. You're making this paddle to move, right? So this work is getting stored as an energy inside this liquid, right? It get agitated, it gains energy, right? So
Yes.
Yes, sir.
Q is 0. What about delta E and W?
Delta E and W will increase.
Very good. Understood? Understood? So answer will be your A.
A.
Understood?
Yes.
Very good. Shall we move ahead?
Yes.
Okay.
Yes, sir.
Till here, any doubt you have? Till here.
Mm,
Acha. Now I'll ask you a question here. Okay? Just understand that question and we'll move ahead. Okay? Now listen. Question is 2 moles of nitrogen gas expands adiabatically, right? With initial pressure, initial temperature, with initial temperature 300 Kelvin from volume 2 liters to 4 liters. Getting it? At constant external pressure. What will be the temperature of surrounding when this process stops? Will you do it by yourself or I should do it?
So we will try it and then we will.
Okay, just do it. Right? Just do it. Just do it. Yeah. Tell me the approach, whatever you follow, the approach which you are following. Okay.
Yes, sir.
What you have done over there? Have you applied P1 even gamma is equal to P2 gamma? Have you applied P1 even gamma, P2 P2 gamma?
No, sir, as external pressure is constant.
Shall I say that it is irreversible process? Shall I say that Q irreversible will be equal to du plus P2 into V2 minus V1? Any doubt? Why I have taken P2? Because P2 is P external. Any doubt in that?
No, sir.
Very good.
No,
Q
sir.
irreversible is 0, correct?
Yes.
So I'll be getting du is equal to minus of P2 V2 minus V1. Any doubt in that? Du is N into Cv into delta T, that is T2 minus T1, is equal to minus of Nr T2 by V2 V2 minus V1. Any doubt? Can I write down P2 as Nr T2 by V2? Correct.
Yes.
Yes, sir.
Yeah. Now
Yes, sir.
understand that N will get cancelled by N. What is Cv for nitrogen?
1.3.
5 by 2 R Cv for
Wait,
nitrogen.
sorry.
T2 minus T1 is equal to R T2. Hey, what is V2 by V1? V2 minus V1? See, this is in liters, this is in liters. So liter get cancelled. That means it is independent of volume right now, isn't it? So final volume was 4, initial was 2, final was 4. So I'll be getting 1 by 2 over here. Correct? Beta, am I right here?
Yes, sir.
Yes,
R
sir.
and R get cancelled. So I'll be getting 5 by 2 T2 minus 5 by 2 T1 is equal to minus T2 by 2. Correct?
Yes.
So from that thing, I got 3T2 is equal to 5 by 2 T1. So I got the final temperature which will be equal to temperature of surrounding, right? Because finally system will be in equilibrium with. So T2 will become equal to 5 by 2 into 3 into what is the temperature? Initial temperature.
300 Kelvin.
So what I'll get here? Understood? Understood?
Yes, sir.
sir.
Very good. Shall we move ahead?
Yes, sir.
Chalo. Now I'll be telling you something about enthalpy, right? This is quick brief about enthalpy. Hey, what is the symbol of enthalpy? H.
H.
Very good. What is H? It is defined as U plus PV. What does it mean? What is the definition of enthalpy?
It is the total heat content of a system at constant pressure.
Hmm. It is the total heat content of the system. That's it. Not at constant pressure at every variable, right? Now tell me one thing. For a particular gas, shall I say the three independent variable will be P, V, and T, which will tell me everything about that ideal gas, right? Number of moles will be depending on this PV is equal to nRT. Number of moles I can calculate. The state variables will be PV and T, which will tell me everything about the gas, correct?
Yes.
The overall energy by T, which is a function of T, is internal energy, right? For a gaseous system, internal energy depends on temperature, right?
Yes.
Yes, sir.
Very good. And because of this pressure and volume, I have PV energy. So shall I say that the total heat content of a gas with respect to all these three variables is enthalpy, right? Now, guys, I'll explain you one thing here. Every time there is very weird question comes like for on a liquid you apply some pressure, there's a decrease in volume takes place. It's very simple. See, for any gaseous process, That means where the constant amount of gas, n is equal to constant, gas is undergoing expansion slash contraction. Any doubt in that? dH is always equal to ncp dt. What is that? Always. What is change in enthalpy? ncp dt. And always remember that dH is equal to du plus d of pv, which is equal to du plus pdv plus vdp. And pdv plus vdp can be written as du plus p2v2 minus p1v1. Sometime you will get a graph type equation or questions where they'll be asking you the stuff like this, that I have a gas which is changing like this, pressure is P1 V1 and final is P2 V2, and they'll be asking you what is the enthalpy change. Understood? So you can use these direct variables here for anything like this. Liquid system is there, gaseous system is there, any solid system is there. You have to use delta H like this. Understood? Understood? Or otherwise use dH is equal to ncp dt for every gaseous process. Any doubt in this? I'm telling you a very important thing right now. If you understand that thing, enthalpy will become simple for you. There is enthalpy in perspective of two. There's two perspective for enthalpy. One is for gases expansion and contraction. For gases expansion and contraction is always equal to ncp. Any doubt in that?
No.
Huh. So whenever a gas is expanding or contracting, it is ncp. Apply ncp, you'll get the answer. Understood? But for a chemical reaction, shall we move ahead, guys?
Yes, sir.
Yes, sir.
See, first perspective is gaseous process. Second perspective is a chemical reaction. Hey, why a chemical reaction is different from a gaseous process over here? Because in a chemical reaction, suppose AA gas is reacting with BB gas to give CC gas and DD gas. Shall I say that the number of moles of gaseous reactant is A and B, the number of moles of gaseous product in C and D. Getting it? So here number of moles of gases changes. In gaseous process where the expansion and contraction takes place, there the number of moles of gases will always remain what?
The same.
Constant. But in this case, the number of moles of gases undergo
Change.
change. Understood? Understood? Now,
Yes, sir.
every time a reaction, in see, one more thing I want to say here. See, for a gaseous process, right, dH at constant pressure is equal to Q at constant pressure, which is equal to ncp dt. Understood? Getting it? dH at constant volume is never equal to Q at constant volume and is also equal to ncp dt. Understood? Because dH is a state function held with the nature of process. It is always equal to ncp dt. Getting a point? Getting a point? So delta H is always equal to ncp dt and is equal to qp. Any issue in that?
No, sir.
Very good. Now come to a gaseous reactant. Sorry, in a chemical reaction. You know what? In a chemical reaction, delta H at constant pressure is equal to QP. That is heat change at constant pressure. And you know what? Delta H at constant volume is equal to QB. You got that? This is a very big difference between the enthalpy perspective for chemical reaction as well as for gaseous process. Did you get that? So
Yes,
in
sir.
case of chemical reaction, I can simply say that whatever enthalpy change is there, it is equal to heat change. That's it. The amount of heat given or absorbed at constant pressure or volume. The amount of heat given or absorbed in gaseous process will never be equal to dH. It will always be equal to Q. In gaseous process, Q and dH are two different terminology. In chemical reaction, Q and DH are what? Same or different in case of chemical reaction?
Same.
Exactly. Now understand that for chemical reaction where the number of moles of gases changes, apply delta H at constant pressure is equal to delta H at constant volume. You know that Q at constant volume is also equal to delta U, that is change in internal energy, or change in internal energy can be represented by delta E plus delta NGRT. Getting it? This is in perspective of what? Never use this formula for a gaseous process. This is a formula for those reactions where the number of moles of gases.
Vary.
Understood?
Yes, sir.
Very good. So proud of you. Now listen. Uh, One more thing. What is work done? Work done in case of chemical reaction is minus of delta NGRT. Understood?
Yes.
Yeah. Every time just remember that when the gases changes happen, so work done in case of chemical reaction is equal to minus of delta NGRT. Done? Understood that perspective?
Yes, sir.
See, this is a
Yes, sir.
big difference between a gaseous process and a chemical reaction. And this is the area where generally student makes mistakes. Okay? So the pitfall. And one more thing, I'm just not sure about whether you know the values or not. For monatomic gas, diatomic gas, polylinear gas, polyatomic linear gas, or polyatomic non-linear gas. CV value, CP value. What is CV value? Monatomic. 3 by 2 R. CP is 5 by 2 R. Diatomic, polyatomic linear, it is 5 by 2 R and 7 by 2 R. And polyatomic non-linear, it is 3 R and 4 R. Understood?
Yes, sir.
Understood?
Yes, sir.
Yeah. So shall we move ahead?
Yes.
Very good. Now listen. This is a brief discussion of delta H. I guess you understood about the DH process, and you understood for gaseous process what you have to do, and for which process?
Chemical reactions.
Now understand that there is a process where phase transformation takes place. Phase transformation. Now understand one thing over here. Suppose solid is converting into liquid. Tell me, this is what? Melting, right? Melting occurs at a temperature which is equal to melting point, right? There's an equilibrium, correct? Shall I say that melting point is the temperature where vapor pressure of solid becomes equal to vapor pressure of liquid?
Yes.
Yes.
That is the definition, right? Now, what do you mean by vapor pressure? Vapor pressure का मतलब क्या है? What do you mean by vapor pressure? Solid का vapor pressure. See, vapor pressure is a tendency of any substance to leave its lattice. Matlab, if a solid particles are there, the tendency of solid particle to leave their lattice and becomes liquid or become gas, or tendency of liquid particle to leave that liquid lattice and become something else. That transformation is known as, or that tendency to leave the lattice is known as vapor pressure. Getting it? Getting it? That is a layman terminology.
Yes, sir.
Very good.
Yes, sir.
Very good. Now, shall we move ahead? Now, listen, in this case, suppose this reaction is taking place, or this phase transformation taking place at constant pressure. Someone is asking me calculate delta H at constant, delta U. What is the internal energy change? So tell me about the internal energy change in this process. Suppose the enthalpy change is delta H. How you will calculate it? See, shall I say that delta H is equal to delta U plus delta of PV, correct? Say yes or no. I say yes or no.
Yes, sir.
So delta H is equal to delta U. Pressure is constant for a chemical reaction. P delta V. Any doubt? Pressure is constant. Volume changes. Volume of solid is different from volume of liquid, right? So initial volume of solid is V1, final volume of liquid is V2. So I have to put here delta U plus P V2 minus V1. Understood? Then I'll get this equation and I'll calculate delta U. Understood? Tell me, in case of water, volume change from solid to liquid is what? Uh, More or less? Delta V is positive or delta V is negative? From ice to liquid, ice to water. From ice to water, delta V is positive or delta V is negative? Guys,
Positive.
Neg.
delta V is positive, right? Sure.
So volume decreases when we go from
Volume
ice to water.
decreases. Why? Because density of ice is
Less than density of water.
ice floats over water. Getting it? Acha, in overall chemistry, no, there are three elements only where the solid part is less denser than the liquid part. Tell me that three elements. Tell me first where
Can you repeat?
in overall chemistry, okay, there are only three elements where the solid part is less denser than the liquid part. I just want to know what all these three elements are. First element will be, first element will be
Ice.
ice is a compound element. Gallium, germanium, bismuth. These are the three elements where the solid density is lesser than liquid density. Understood? Are you understood?
Yes, sir.
Now tell me one thing. Suppose a question is asked. Germanium solid is in equilibrium with germanium liquid at its melting point. And they have asked you zinc solid is in equilibrium with zinc liquid. Okay? Now, what about delta H and delta U relationship? What about delta H and delta U relationship? Here. Which is bigger? When volume change, here volume change is positive or negative?
Negative.
So this delta V is negative, right?
Yes.
That means delta U becomes greater than delta H, right?
Yes, sir.
Turn on the system. So internal energy increases further. So delta U is greater than delta H. And here,
Delta H is greater than delta U.
understood? Understood?
Yes, sir.
Great. So these small difference actually makes a big thing. Now you understand the whole perspective of enthalpy. For gaseous process, what do you have to do? For a chemical reaction, a number of moles of gases are changing, what do you have to do? And for the phase transformation, what do you have to do? Right? Right?
Yes, sir.
Very good. Now, listen. This is a question. Assume in each reaction is carried out in an open container. That means there's some work done. Closed container means work done is constant volume means work done is
0.
0. Right? Now assume each reaction is carried out in an open container. Now tell me exactly where delta H and delta E will be same. What is the relationship between delta H and delta E for a chemical reaction where number of moles of gases changes?
Delta H is equal to delta E plus delta NGRT.
That means delta Ng should be equal to what?
0.
So change in
0.
number of moles of gases. That means change in the stoichiometry of gases should be equal to
0.
yeah. So tell me where it is like that.
Option
Bombay.
B.
Understood? Correct.
Yes, sir.
Here in this question. Tell me fast. This particular question.
Sir, Bombay.
Okay. Because delta Ng. What is the delta Ng stuff here?
-3.
Yeah. So delta H minus delta is equal to -3 RT. Everyone got that?
Yes, sir.
Yes.
So these are the previous year questions, right? They seems to be very what? Simple or tough? Guys. What are they? Simple or tough? Very cheap, right? Now listen. The nightmare for all of you. What is that?
Chemistry.
Chemistry is not a nightmare. It's some chapters might be, right? Entire chemistry can never be, right? Hey, what is that? Entropy, right?
Entropy.
Now, tell me how to deal with the entropy stuff. Hey, what is the definition of entropy?
Degree of randomness.
It is the measurement of degree of not the amount of randomness, chaos, disorderness of a system, right? Right. Now, understand that ds is always equal to q reversible by t. Getting it? And according to second law of thermodynamics, it says that ds, that is change in entropy for universe, for spontaneous process is
Always positive.
very good. Spontaneous process means irreversible process, right? Is always greater than 0. Understood? That is ds of system plus ds of surrounding for an irreversible process is greater than 0. Take care. Now, what about entropy change for non-spot, sorry, reversible process?
Sir, it would be change in S is equal to Q reversible by T, which is S final minus S initial.
One second, one second. That is correct. But the thing is, change in universe, ds change in entropy change for universe for a reversible process, right? Reversible process. It is always equal to
0.
yeah. Understood? Understood. Hey, why is it so? Can you give me a logical answer for our answer for that? Tell me, whenever an irreversible change occurs, think about it, right? The temperature of system is T, and this temperature is in equilibrium with surrounding temperature, right? Correct.
Correct.
Yes, sir.
And let's say every time temperature changes, suppose final temperature from temperature T, it becomes T1. This temperature will also become T1 because both are in equilibrium, right? And every process temperature changes. Agreed?
Correct.
Now understand here, let's say system is giving out heat. If system is giving out heat at temperature T, then surrounding will, if I am giving heat, then surrounding which is encapsulating me will absorb heat.
Absorb the heat.
So for me at that particular stage, at that particular stage, the entropy change will be minus Q by T because I'm losing that energy, right? And for surrounding, it is gaining the same amount of energy at the same temperature. So this is ds for me, this is ds for surrounding. What is change in ds? What is the net change in ds? Are you getting my point what I'm trying to say here, guys?
So
I'm
what was your original question?
uh, prove that ds of universe for reversible process is equal to 0. That was the original question. Why is it so? Getting it? So I assumed a process which is reversible, and I told you that in every reversible process, the system and surrounding will be in.
Equilibrium.
That means every time temperature of system and temperature of surrounding will be same. At temperature T, it is giving out energy Q. So if it is giving out energy Q, the surrounding is absorbing the same energy at the temperature T. For system, ds will become, entropy change will become minus Q by T at that point. For surrounding, it will become Q by T at that point. The net summation becomes,
0.
getting it? And listen, one more thing. If it is irreversible process, the temperature of system is T and the surrounding is T dash, right? It is giving out energy. So it is giving out energy at different temperature and it is gaining at different temperature. So is it possible that every time ds is same?
No.
Very good. That is why for irreversible process, net summation comes out to be positive. And in overall process, irreversible process, because the things happens at the same point. Is this temperature, it is giving, it is absorbing. At this temperature, it is giving, it is absorbing. It is this temperature, it is giving, it is absorbing. So at every particular temperature, the same thing is happening. So entropy change is negative, positive, negative, positive. The summation becomes, for reversible process, becomes
0.
exactly. You understood that, feel right? Got that?
Yes, sir.
Yes, sir.
Now we'll study the entropy change right now. Okay. Now we'll calculate the entropy change for various process. Now entropy change. Now first thing I want to calculate the entropy change for gaseous process. Just now we know that ds is equal to q reversible by t. Agreed?
Yes.
Now for gaseous process, tell me, shall I say ds of system? System की बात करते हैं, right? We talk about system. ds of system will be equal to q reversible of system by t. Correct? What is q reversible formula? It is du plus p internal dv. If you remember, instead of p external, what I have to use? What I have to use?
Internal.
Right? Understood? Now tell me, what is du? ncv dt by t plus pdv by t. Agreed?
Yes.
Very good. Shall I put pv is equal to nrt over there? If pv is equal to nrt, then p will become equal to nrt by v. I'll put that p over here, right? Right.
Yes.
Yes, sir.
Yes.
So
Yes.
what I'll get here, ds is equal to NCV dt by T plus NR dV by V, because T and T will get cancelled, correct? So integration T1 to T2, integration from V1 to V2, and integration from S1 to S2. So I'll be getting delta S is equal to, hey, what is dt by T?
ln
Ln
T2 by
ln
T1.
V2 by T1 I'll get, and dV by V is ln nr ln V2 by V1. That means, listen, guys, delta S of system for any gaseous process, please use this formula. You'll get the answer. Any damn process, whether it is reversible process, it is irreversible process, you can apply this formula to calculate delta S for because entropy is a state function. It does not depend on the nature of process. For a particular process, I have calculated delta S of system. Use that delta S of system everywhere. Understood?
Yes, sir.
Right? Shall we move ahead?
Yes, sir.
Sorry. Yeah. Now listen. Yeah. We're talking about entropy. Okay. Now understand now. We know that ds is equal to NCV ln T2 by T1 plus nr ln V2 by V1. I can use it for any gaseous process. Okay. That is delta S of system. I can calculate that. Okay. I have a doubt. Acha, one more thing. NCV ln T2 by T1 plus nr ln V2, I can write it as nr T2 by P2, and V1 I can write it as nr T1 by P1. nr get cancelled by nr. It'll become NCV ln T2 by T1 plus nr ln T2 by T1 plus nr ln P1 by P2. Just add, take common, add these things. CV plus R becomes CP. So I'll get NCP ln T2 by T1 plus nr ln P1 by P2. Understood? Guys? Either you use this or you use this, you'll get the same thing because one of the same formula. Now, listen, I want to ask something. I am a system. Guys, what I am?
System.
See, what I'm doing an irreversible process. Irreversible process, a very large process, right? Right?
Yes, sir.
Now, listen, what I'm just doing some work on this particular desk, right? See, I did some work. Is it reversible or irreversible? Baba, reversible or irreversible?
Irreversible.
Irreversible.
I have lost large amount of energy, right?
Yes.
To whom?
Yes.
To whom I have lost?
Surrounding.
Sound energy.
So if I'm giving surrounding large amount of heat, the surrounding should become hotter, right? I should feel heat, a warmth, right? Is it happening? You do a process, that means surrounding becomes hotter. Is it like that? Or the temperature of surrounding changes?
As the surrounding is very vast and big, the temperature increase is negligible.
If the negligible change is occurring in a particular process, the process is reversible or irreversible? If a
Reversible.
negligible, reversible, that means if I'm doing an irreversible process, I am giving energy irreversibly. but surrounding is absorbing that energy in an
Reversible manner.
Reversible.
understood. So the process which occur in a surrounding is reversible or irreversible?
For the
Reversible.
surrounding
Reversible.
Now listen, the
irreversible.
same thing I'm doing reversibly. I'm doing very small change like this. So I lost energy negligibly at every small step, small amount of energy I've released. Does temperature of surrounding changes?
It will increase negligibly again.
That means again the change in the surrounding is
Negligible.
reversible. That means as a system, I can do reversible process or irreversible process, but the corresponding change in the surrounding is always.
Reversible.
Reversible.
Now understand this particular terminology. This person is doing a process which is irreversible. It has given energy Q irreversible of system. Any doubt? Any doubt? समझ में आया जो बोला है
sir.
यहाँ पे? Did you understand what I'm getting here or what I'm
Yes,
telling
sir.
you? Right? Now tell me, if it is giving out Q irreversible of system, then surrounding will absorb it in an which way?
Reversible.
Reversible.
Q reversible of surrounding will be equal to minus Q irreversible of system. True or false? Baba, true or false?
True.
True. Getting a point? And suppose this system is giving Q, a reversible process is happening. So it is giving Q reversible of system to the surrounding. Then surrounding will absorb this energy reversibly only.
Yes, sir.
Yes, sir.
Clear, clear.
Yes, sir.
That means surroundings always undergo which process?
Reversible process.
Reversible.
A very important thing. Getting it? Understood?
Yes, sir.
Yes, sir.
Nice. Now, entropy change in case of phase transformation. This is the last topic of the day. Then we'll wind up. Okay? Then we'll start the session. Normal, regular sessions. Sorry. Okay. Now, entropy change in phase transformation. Suppose I have ice, m gram of ice at minus 100 degrees Celsius. Or what temperature? Minus what? 100 degree. It is converted into steam. Same m gram steam at 200 degrees Celsius. He is asking me calculate the delta S overall. Did you get that? Guys, did you get that?
Yes.
Now, there are certain information which is given to me that latent heat of fusion is equal to 80 calories per gram. Latent heat of vaporization is equal to, let's say, 540 calories per gram. Other information is given to me as specific heat of ice is equal to 0.5 calories per gram per Kelvin. Specific heat of water is given to me as 1 calories per gram per Kelvin. specific heat of steam is given to me as 0.5 calories per gram per Kelvin. Agreed? Tell me, delta is a state function or a path function? Yes, state function or path function.
State function.
State function.
So shall I say that I'm dividing this overall process into multiple small things, right? What are the multiple small things over there? First, I'm converting ice minus 100 degrees Celsius to ice at 0 degrees Celsius. Any doubt?
No.
You don't know why I'm doing that, because from 0 degrees Celsius ice, I'm converting it to
0-degree water.
0 degrees Celsius water. From 0 degrees Celsius water, temperature increases till
100 degrees Celsius.
100 degrees Celsius water. 100 degrees Celsius water will get converted into
100 degrees Celsius steam.
very good. The temperature doesn't changes in that conversion whenever the phase transformation takes place. So 100 degrees Celsius steam. 100 degrees Celsius steam to 200.
200 degrees steam.
Now understand one thing here. Now this is delta S1, this is delta S2, this is delta S3, delta S4 and delta S5. Sorry. Here temperature changes. Here temperature remains constant. Here temperature changes. Here temperature remains constant. And here temperature changes. Okay. Now the process where temperature is changing, I have to integrate that particular process at every temperature, so that at every temperature change I can calculate delta S, right? And the process where temperature doesn't change, I need not integrate it. Did you get that? Did you get that? Because temperature remain constant, at a very constant temperature it is gaining energy. Just do Q by T, you will get the answer. Did you get that? See, the process where every point of time temperature is changing. So at temperature T1, some Q is coming, so Q by T, and temperature T2, Q by T2, Q by 3T, Q by T3. So I have to add all this ds, right? So I have to do integration. If the temperature doesn't changes, so Q by T, I need not do integration, right? Just calculate Q divided by T. Getting my point? Guys?
Yes, sir.
Yeah. Shall we move ahead? So tell me, where the temperature does not changes. I know the amount of energy utilized over there is mass into LF. Here it is mass into LV. Getting it? So delta S2 is very simple for me. Mass into LF, that is latent heat of fusion, divided by temperature 273 Kelvin. Here delta S4 is equal to mass into latent heat of vaporization divided by 373 Kelvin. Any doubt in that?
No, sir.
Very good. Now to calculate delta S. Now tell me, whenever the temperature change is happening, the Q is given as mass into specific heat into change in temperature. Agreed?
Yes, sir.
Yeah. Now understand that with the temperature changes, there it is ms dt. Why I'm not doing ncp dt? Because it is specific heat. So specific heat I have to multiply it with mass. It is per gram. If it is per mole, I have to multiply it with mole. That you can do, right? If the units are given in per mole, you have to multiply it with mole, right? To get the values in calories.
Yes, sir.
Yeah. So if it is in mass, you have to use grams only, right? Per gram is given, so you have to use mass only. So I have like ds1 is equal to integral of ms dt, that is q by t. From temperature changes from like what is the temperature changes? Minus 100 degrees Celsius to 0 degrees Celsius. That means minus 173 Kelvin to 273 Kelvin. Any doubt? Hey, what is integral of ms dt by t? Dt by t is what?
ln dt by t.
ln.
ln, this is specific heat of ice, ln 273.
273 by 170.
Very good. What is ds2 integral, or ds3, sorry, where the temperature changes? Here, mass into specific heat of water, again dt by t, integral from temperature 273 Kelvin to 373 Kelvin. Agreed? Say yes or no?
Yes.
So m into s ln 373 to 273. Correct? Right?
Yes, sir.
Here ds5 integral is equal to m into specific heat of steam into ln 473 by 373. Agreed? Add this, add all the delta s, you will get the final delta s. Understood? Guys, understood?
Yes, sir.
Yes, sir.
Any doubt in that? Any doubt in that?
No, sir.
In next thermodynamics class or next class, we will complete the thermochemistry also. Getting it?
Yes, sir.
Hope you understood some things today. Okay? Enjoy.
Yes. Thank you, sir.
Okay, take care. Bye.
Thank you, sir.
Okay, beta. Take care.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.